Welcome student, myself Rahul Singh Maur, Assistant Professor in Mechanical Engineering in MLB Textile and Engineering College. Today in this video, we will study comparators, and under this category, first we will see pneumatic comparators. In previous video, we have completed CMM coordinate measuring machine, and today's we are going to start comparators, and under comparators we will study pneumatic comparators. As we know that all measurements require the unknown quantity to be compared with a known quantity called a standard. For example, if we are going to market to buy vegetables and we asked the grasshopper to give 1 kg of vegetable, so how the person calculate that the weight of the vegetable is 1 kg. So what he did, he compare the weight of the vegetable with standard, the standard having a mass of a weight of 1 kg. So when he compared the weight of vegetable with 1 kg standard weight, then he decide that much amount of vegetable is equals to 1 kg. So to measure unknown quantity, we compared that quantity with standard one, and then we decide the value of that unknown quantity. So there are certain devices in which the standards are separated from the instrument. It compares the unknown length with the standard. Such measurement is known as comparison measurement, and the instrument which provides such comparison is called comparator. Comparators are generally used for linear measurements, and various comparators available differ basically in the methods employed for amplifying and recording the variation measured. Basically, there are four types of comparators: pneumatic comparators, mechanical comparators, optical comparators, and electrical comparators. Today, we will see first pneumatic comparators. Pneumatic comparators, it works on the principle of pressure difference generated by the airflow. As the comparator's name is pneumatic comparators, so it is already cleared the working medium we used are air. So air is supplied at constant pressure through the orifice, and air escape in the form of jet through a restricted space which exert a back pressure. In this image we can see when air is blowing from that restricted area and it strike on the wall, we move the pneumatic comparators along this direction. So when there is any change in the surface of the measuring surface, so what happen, the pressure of air ejecting from the restricted area changes. So based on the pressure difference, we calculate the variation in the surface. For example, if the surface is smooth along this direction and we move parallel to this surface to our comparators, then there is no pressure difference observed during the movement of the comparators in this direction. So pressure remains constant. So we can say that the surface is straight. Advantages of the pneumatic comparators are: it is cheaper, simple to operate, and the cost is low. It is free from mechanical hysteresis and wear. The magnification can be obtained as high as 10,000x. The gauging member is not in direct contact with the workpiece as we saw in the figure, indicating in the measuring is done at two different places. And as in fourth point it is mentioned that gauging member is not in direct contact with the work, so our workpiece is safe, no harm from our comparator to the workpiece. Taper and obliquity can be easily detected. The method is self-cleaning due to continuous flow of air through the jet, and this makes the method ideal to be used on shop floor for online control. Similarly, there are some disadvantages also. They are very sensitive to temperature and humidity changes, because we know that as the temperature and humidity changes, the properties of the air also changes. So it is difficult to measure the correct values. The accuracy may be influenced by surface roughness of the component being checked. Different gauging head are needed for different job. Auxiliary equipment such as air filter, pressure gauge and regulator are needed. Non-uniformity of scale is a peculiar aspect of air gauging, as the variation of back pressure is linear over only a small range of the orifice size variation. Thank you so much.